I think you could do this limit better than a rock. So all we have to do here is evaluate this limit as x approaches 1. Now this limit requires the function multiplication law of limits. Now this law is handy for many applications, but if you're able to multiply functions like we have here together inside of our limit, it might even just be easier to do that. Why do I say that? Well, let's try to take the limit of our f of x function first. You see, everything looks fine here until you realize that if we used 1 for x, that would give us a denominator of 0. And as you know, that is not a good sign. And so by itself, the limit wouldn't exist, because the left and the right-sided limit wouldn't agree. But if we rewind a little bit, this problem is a little clever. You see, the limit here would be does not exist, but if we multiply it with this, like the problem says, the answer works out a little differently. But first, we would need to factor that. And so using whatever method you can, go ahead and factor out 2x squared minus 2. So now looking at the functions together with the g of x factored, hopefully you can see a little thing that's going on here. Because if we multiply g of x and f of x together, we realize we are multiplying a denominator by a factor in our multiplication sentence. And so by multiplying these functions together, we're actually getting rid of the does not exist. And that just leaves us with x times 2x plus 2, or simplified 2x squared plus 2x. And so that was only possible if we multiplied these two functions together first. So now instead we can find the limit of 2x squared plus 2x. And we know we have two functions right here, and we can find the limit of each one. 2x squared plus 2 becomes 2, plus 2x becomes 2 again, which equals 4. So the limit as x approaches 1 equals positive 4. I hope this little walkthrough helped. Let me know your thoughts down below.